My name's Austin Coates, and I wanted to talk to you today about a really cool case study that I did on the CalWood fire and computing safety zones for wildland crews. So the CalWood fire occurred just actually right outside my door. That's the reason I was interested in it is because it could see the flames from my front door. And so this occurred near Boulder, Colorado, and it was started on October 17th in 2020. It was 100% contained on November 14th, and it burned 10,000 acres. So, in thinking about this fire and looking at it burning, I started to think, wow, wildland crews have a very, very dangerous job, and the men and women must take extreme precautions to make sure that they're safe while fighting fires. And I started to look into that a little bit more, and I came across these really interesting papers. So, one was done by Dr. Dennison called Identification of Firefighter Safety Zones Using LiDAR, and then the other one was done by Dr. Campbell called Safe Separation Distance Score, a new metric for evaluating wildfire fighter safety zones using LiDAR. And in reading through these two papers, I thought, I'll give it a shot. These algorithms look like they could be easily modeled up. And so, yeah, I give it a go. So what is a firefighter safety zone? So a safety zone is a location where a threatened firefighter can find adequate refuge from an approaching fire. This is an area where a fire shelter is not required. So you can think of it as an area where you could park a pickup or stand and you wouldn't get burned, nor would you need to deploy your shelter. So how do you compute one of these safety zones? You do it by looking at 4 times the flame height. So let's say you had a 1 foot tall flame, you would then need to stand 4 feet away from that flame to not get burned. And then a nice proxy for flame height is actually 2 times the vegetation height. So if you put those together, you have 4 times 2 times the vegetation height, and that will give you safe separation distance. And so I wanted to find all of the areas within the CalWood fire region that were safe to stand, essentially. So the way I did that was I acquired LiDAR imagery over the area, and I took the elevation, the digital elevation model, the DEM, and subtracted the surface model from that and came out with the canopy model. And then from that, I found where each location of a tree was using our crop counting tool inside of ENVI. And then I also took sentinel imagery, and for each one of those tree locations, I pulled out the health of the tree. And from those tree locations as well, I computed a safe separation distance. So I did it all using an NV model because I wanted to make sure that I could iterate over it, and if I ever wanted to run it on a different area and swap out the imagery, I could. So it looks like this. So this model will find all the trees and compute the mean normalized difference vegetation index per tree. So this is essentially the health of each one of the trees, and it was a nice layer to visualize. And then this was used to compute all of those safe separation distance layers. So right here between the 2 orange boxes, this is where all the hard work happened, and it looked like this. So don't be intimidated. Each one of these essentially is just a replicated task over and over, and it's just essentially 1 times the vegetation height, 2 times the vegetation height, 3 times the vegetation height, 4 times the vegetation height, and then I stacked them all together to get my final representation. So let's take a look. This is the perimeter of the fire. This is the location of all of the trees colored by their NDVI values. So a value of 0 or a senescent or dead tree would be red, and then a value of 0.7 would be green or very dark green. And so those are kind of your healthy trees. Here's a nice little zoomed in image, so you can see the underlying imagery is actually the sentinel imagery, so it has a much higher or much lower spatial resolution than the LiDAR imagery, and that's why you kind of have that boxy effect behind all of those small tree locations. And now this is the safety zones. So anywhere that is blue would be a safe area to stand, and anywhere that is red would be either actively on fire or way too close to the fire to stand. And so these are computed by the red areas are 1 times the vegetation height, whereas the dark blue areas are 8 times the vegetation height. And then here's a zoomed in look at that. So if you look at this area down here, you would want to stand kind of in the center of this, and that would be a safe area to stand. Whereas, for example, the red areas probably are are way, way, way too close to the flames. So here are the results. So this is the digital surface model subtracting the digital elevation model, and that gives me the height of each one of the trees. This is the next one here is the location of each one of the trees colored by the NDVI, so red being senescent trees and dark green being nice healthy trees. And then once again, this is the safe separation area. So 1 times flame or 1 times vegetation height, 8 times vegetation height being blue.